right, what we're working with today is solving and graphing absolute value inequalities. Well, first of all, we have to remember what an absolute value is. Remember, an absolute value is just the distance a number is from 0. And because it doesn't matter which way I go, if I go over here, I go a distance. And if I go over here, I also go a distance. Even if you go to the left, even if you go negative, you're still going to have a positive distance. So the absolute value can never be a negative number. Okay, so now this time it's going to be a little different because it used to be with equations, if you got it equal to a negative, then it was a no solution. But if this is my number line, these are my negatives, and these are my positives over here, my answer always has to be over here somewhere. It has to be in the positives. So if I have a problem that says the absolute value of x is greater than -2, well, -2 would be right about here. Change colors. -2 would be right about here. Is this point, these blue points, to the right of -2? They are. So this works. This is okay to have. When you're going to run into issues is when you have something that says the absolute value is less than a negative. So again, if I have my -2 over here, if I'm less than, I'm this way, which means I have to be a negative. So this one here is a no solution. You can't have this. Change that to red so it stands out. So this one is a no solution. So the difference is the one that's okay, it's greater than, and it passes through the positives. So that has to be an answer. But the one on the left, it goes to the left, which is less than, and it doesn't go anywhere to where your possible answers could be. So that's why there's a no solution. All right, so when we graph these, when it's a less than, these are and problems, and you'll see why that happens. So remember, our first problem is that we first of all draw our arrows down, which is the same process. My first one stays the same. But my second one, remember I changed it to a -3. But changing to a -3 is going to make me flip my inequality. And the reason I do that is because my first answer would be x is less than 3, which I have. But my other one would be a -x is less than 3. And when you divide by -1, it flips it. So remember, the rule on the right is you're going to change the sign and flip. So if I graph this, at +3, it's an open circle going to the left. And at -3, it's an open circle going to the right. So this is an intersection. So that's why it's an and problem. On the left, these end up being or problems. And so my first one stays the same, x is greater than 3. But my second one, again, when I change the sign to -3, I flip the inequality. Your inequalities need to be facing two different ways. So now when I graph it, at +3, it goes to the right. And at -3, it goes to the left. Now, if you get confused on whether a less than or greater than is an and or, it really doesn't matter. You'll be able to find the answers by graphing them and see where things overlap or where they go other directions. All right, so one thing that's nice about this is it's the same steps. The first thing you have to do is get your absolute value alone, meaning if you have the absolute value of x minus 2 is greater than 3, you would have to get rid of this 2 before you could break it down. Same thing if I had the absolute value of x, or 3 times the absolute value of x is less than 5. I couldn't do anything until I got rid of this number. Not that one, this one right here. Okay? So you have to get the AV alone. Second step is you have to check if it's positive. So there's two options. It has to be greater than a negative or anything with a positive. If it's greater than a negative or any positive, then you go to this step where you break it down. And remember, this side, you change sign and flip the inequality. So when you have this situation where it's less than a negative, that's a no solution. Okay? Last step, once you separate them and you know you could do it, you just solve each one and graph. All right, so what we're going to do is we're going to try some problems. My recommendation is pause and copy it down and try it on your own first and then come back and see. So if you notice, my absolute value here is alone. So I can see it equals a positive. So I'm good. So now I'm going to break it down. So the first one, there's my mouse, stays the same. 3x plus 6 is greater than 12. The second one is where I have to flip the inequality and make it a negative 12. You should notice, though, that the inside stays exactly the same. So now I'm minus 6 on both sides, and I get 3x is greater than 6. And I divide by 3, so x is greater than 2. Insert some more space. And then on the right, same thing, I'm going to minus 6, and I get 3x is less than negative 18, divide by 3, and I get x is less than negative 6. Don't flip here. A lot of people are starting to flip because you get a negative answer, but I divided by a positive, so I don't flip. So I'm going to graph this. At 2, it's an open circle, and it says greater than, so it goes to the right. And at negative 6, it's an open circle and it says less than, so it goes to the left. So there's your answer for that. All right, let's look at number 2. For number 2, my absolute value is not alone. I have to get rid of this thing right there. I got to get rid of that. Oops. I have to get rid of that. Okay, so I'm going to add 4 to both sides. And so I get the absolute value of x minus 2 is less than 7. Now my absolute value is alone. So now since it's alone and it's a positive, I can go ahead and break it down. So I get x minus 2 is less than 7. And then the other one is x minus 2 is greater than negative 7. Because remember, you change the sign and flip the inequality. So I add 2 to both sides, and I get x is less than 9. Add 2 to both sides, and I get x is greater than negative 5. So at 9, it's less than, so it's an open circle going to the left. At negative 5, it's an open circle, and it's greater than, so it goes to the right. So this makes the barbell. All right, for number 3. Let's look what we have to do first. Again, you look to see what's not alone, and the absolute value has stuff with it. So the first thing I'm going to do is I'm going to get rid of this plus 4 by minusing 4. Remember, you always add or subtract first before dividing or multiplying, majority of the time. And now I'm going to divide by 2. And so I get the absolute value of x plus 5 is less than negative 1. Whenever you see a negative, you need to check the rules. So let's go back and look at the rules. And the rules say it has to be greater than a negative. It's not greater than a negative. So since it's less than a negative, it is a no solution and you're done. All right, looking at number 3, first thing I need to do is see if it's alone, and it's not. It has this negative 3 out front. So I have to get rid of that. And the way you get rid of that is you divide by negative 3. Now, because I just divided by a negative, what should I be doing? That's right, I have to flip my inequality. 9 divided by negative 3 is negative 3. Now, since I have a negative, I'm going to go back and look at my rules. And look, it has to be greater than a negative, which it is. So this one I can do. So I'm going to break it down. And it's going to be x over 4 minus 1 greater than negative 3. And x over 4 minus 1 less than positive 3. So I add 1 to both sides, and I get x over 4 is less than negative 3. Times by 4 to get rid of a divide, and I get x is less than negative 12, or greater than negative 12. And then on the right, I add 1 on both sides, and I get x over 4 is less than 12. Oops, look at what I did. I just caught this. This right here, let's erase that. Hopefully some of you caught it too and said, Ms. Razor, you're making mistakes. So my problem right there is, let's fix this. I'm going to change colors so you can see where my mistake was. Right here, negative 3 plus 1 is a negative 2. So negative 2 times 4 is negative 8. Usually you won't have the same answer, a negative 2 and a positive 12. So that's kind of how I knew that I made a mistake. And I made another mistake. Holy cow. So right here, I was jumping the gun. I was looking at my other problem. So here, 3 plus 1 is 4. Where's my mouse? Oh, there it is. So now I multiply by 4, and I get 16. So several mistakes on that one. I apologize for that. But that way, hopefully, you see people do make mistakes. I don't do it on purpose, and then I try and catch them. So at negative 8, it's an open circle to the right. And at 16, it's an open circle to the left, so it makes a barbell. So the big thing to remember here is that absolute values cannot be less than a negative. If you have a negative, it must be greater than a negative.